Hi, hope you guys have had a Merry Christmas. It's the 26th today, and it's pretty snowy. Well, it's not snowing now, but it snowed. So anyway, yeah, so I am continuing in this book. This is I've done a lot of stuff on this out of this book already. I'm basically using this as a guide with reference to the actual figures in philosophy of mathematics. So I'm using this as a guide, but mostly this is discussion in chronological order from Plato to Aristotle, Kant, Mill, and then to Logicism, formalism, and intuitionism. Those big three mostly, and then it goes to what is contemporary. So essentially, what I'm doing here, this is a video. Because I did two videos about Frege. There were videos about Frege's philosophy of mathematics and his idea of number. Because essentially what there is here, this is Logicism. Logicism is the attempt to show, for one, that mathematical entities and mathematical principles are reducible to logical entities and logical principles. And also, what Frege was trying to do, his goal was to build his arithmetic on top of the logical principles that there were, the axioms, and essentially, and I have two videos on this. You can go back and watch them. There's just two videos about him, about Frege, referring to different things about him. But this one is going to be about Russell, mostly Russell. This is going to be referring to Whitehead, to Alfred North Whitehead a little bit, because he had a part in writing Principia Mathematica, which is what Russell's Logicism mostly came out of. There was, following books in his mature age, where he wrote things there that are also important, but it's mostly talking about this Principia Mathematica, because that is where this Logicism came from, out of Russell. But essentially, in one of the Frege videos, I talked about how Frege had these axioms, these logical axioms, and he was going to build the arithmetic on top of those. So this is a foundationalist philosophy, and he was going to build his arithmetic on top of this logic. So he had this system, he had this program where there was this thing called the Basic Law 5. Basic Law 5, Frege's Law 5. For any concepts f and g, the extension of f is identical to the extension of g, if and only if for every object a, f of a, if and only if g of a. So this is mostly saying that the concepts f and g, for these concepts f and g, the extension, meaning the objects falling under it, of f is identical to the object's extension of g if for every object if the objects a fall under both the concepts g and f. So that's essentially what it is. And then in this correspondence between Frege and Russell, this whole program just kind of came to a crumble, because Russell gave his paradox. I have a better explanation of Russell's paradox there's one of the Frege videos I have is called Frege's Law 5 and Russell's Paradox, which explains what Frege's program was, and furthermore, it goes into deep detail of not deep detail, but like a good amount of detail about, and plus an example of Russell's paradox as to how paradoxical it is, and how this proves Frege's Law 5 inconsistent, and makes Frege's whole thing just kind of fall apart. Even though there are a lot of things that one can take away from Frege's work, but essentially the whole issue here is there is this idea of an impredicative definition, or the vicious circle principle. Now, this is a little thing from Russell that I would like to read. Whenever, by statements about all or some of the values that a variable can significantly take, we generate a new object, this new object must not be among the values which our previous variable could take, since if it were, the totality of values over which the variable could range would be definable only in terms of itself, and we should be involved in a vicious circle. For example, if I say Napoleon had all the qualities to make a great general, I must define qualities in such a way that will not include what I am now saying, i.e., having all the qualities that make a great general must not be itself a quality in the sense opposed. So an impredicative definition is defining a certain. It's defining let's say we're defining a class and a concept which creates this class, and the extension of the concept being the class. It's like what the concept of or what the class is cannot be within the class. It's like with the example, Napoleon had all the qualities that make a great general. The qualities that make a great general cannot be in the concept of qualities if this definition is to be predicative. So, and then this is more Russell's paradox. So, what the whole deal here is that this impredicative definition and the vicious circle principle, this is going to lead to all these problems with this basic law 5. It's going to lead to Russell and Whitehead's new way of looking at numbers, and it's called type theory. Now I'm going to go into why impredicative definitions mean something here, but I'm going to just kind of discuss this idea of types. But first, Russell says that it must, under all circumstances, be meaningless to suppose that a class is a member of itself or not a member of itself. Okay, now that is it's meaningless to discuss whether a class is a member of itself or not. Now that is probably gonna make some things easier rather than harder, because when you think about the idea of a class being a member of itself. Now, when you think about the Barber paradox, or even the Napoleon example, that is going to make it easier. But if you think about a class being a member of itself, a class is essentially something. It's something that groups a bunch of objects by the identity of a concept. So it's mostly an extension of a concept, mostly. Where was I? Close. So that makes everything easier to say that it's meaningless to think about that. And then it's even more okay. Thus, this is from Shapiro. Thus, there can be no all-inclusive class that includes all the classes in the universe, since this domain will be a member of itself. Nor can there be a class of all classes that do not contain themselves as members. For Russell, it is meaningless to say or even assume that there is such a class. He proposed a type theory which partitions the universe, to find an individual to be an object that is not a class. Individuals are of type 0, and classes of individuals are of type 1. Classes of individuals are of type 2, and so on. So, this is like Frege, to denote the number 1, would use a little set, brackets, the squiggly ones that have a pointer on the side of the, not the parentheses of the brackets, but the ones that denote a set. It would be the number 0 in there to denote that. Now, the number 0 for Russell is the empty set. The number 1 for Russell is 0 in is 0 in parentheses. So essentially, with this type theory, what the number 2, the number 1 is the classes of only one is the number 1 is how do I explain this? Number 1 is the number that you gain from the logical idea of classes containing only one member. Number 2 is the number that you get that comes from all pairs. Number 3 coming from everything that contains the classes of triples. So this is a type theory. Type 0. Type 0 meaning individuals. Type 1 being classes. Classes of type 2. Classes of type 3. So this is the way of classifying individuals. Now, I guess I want to think about Frege's realist ontology here, because if we can think of this as logical principles, then what we're doing here is we're taking logical ideas of classes and with Russell, think about types, and you get numbers out of that. Now that is a logicist idea. But I guess this is a good thing, and it prevents problems like that. But then we have this idea of something called a level, which a level 0 a level 0 something is something that is predicative. Level 1 is something that is impredicative. But I guess this video is mostly to consider these new things that I guess, I mean, I could go into these much more deeply. There's a lot of things that one could go into with Russell in Whitehead's Principia Mathematica, as well as Russell's other mathematical writings. There's a lot of things that one could go into, but my concern here is considering the things that Russell did, given his paradox, which crumbled Frege's program, and thinking about what his problems were. Because basically what set his idea apart from Frege is that Frege would have this idea of a number in Frege would he would violate this type theory where he would like put 0 and 1 as a pair in a bracket in the set bracket, and something like that. There would be one of those numbers would be type 0, one would be type 1, or 1 would be type 1 would be type 2, and now I guess the difference between Frege and Russell is that Russell actually looked at things as classes instead of concepts. That's the dividing line. Is that Frege looked at F and G as concepts, and that the objects as extensions of concepts, and Russell moved to actual classes, and and there's something funny that he says later that is interesting, but Frege's, let me think about this. Frege's number 1 is the number of 0 with the little set brackets around, but 0 with the set bracket around is type 3, and so the number of this class is of type 4. Notice that even though the number 0 has a single member, 0 is not a member of Russell's number 1, since the latter contains only type 1 classes as per the type restrictions. Since the number 0 is of type 2, it is a member of type 3 class, consisting of all type 2 classes that have a single member. To help keep types straight, let us anyway, the whole idea, the whole division here is that Frege didn't. I mean, Frege was moving towards this idea of this class theory. He was moving towards looking at everything as classes. You can see that in lots of his writings, and you can see that. But the whole division between Frege and Russell is that Russell accounted for impredicative definitions with with type theory, as well as the notion of a level. But I guess and then Russell also has various definitions of what a natural number and a cardinal numbers are, and that's very there's lots of stuff to read by Russell on this topic. But I'm concerned with these little axioms that he brings about. He has 2 very important axioms. He has 3. He has another one later, which is very important, I think, also. Okay. The axiom of infinity. This axiom says there are infinitely many individuals Now this, if this is a big problem, this is a big issue in philosophy of mathematics. The idea of what is infinity. Now this axiom says there are infinitely many individuals. Now the question here is this principle, is this axiom analytic? And that would be no. Can you prove this? No. Is this a priori? No. Is it true by virtue of necessity? No. So, because like Shapiro gives a pretty good example here. For Russell, whether a given natural number exists depends on how many individuals, i.e., non-classes, there are in the universe. Suppose, for example, that the world contains exactly 612 individuals. Then Russell's number 612 would be the class of all 612 membered classes of individuals. There would be only one such class, the class of all individuals. To follow the definition, the successor of 612 is the number of the class consisting of the universe, together with x, where x is any individual now belonging to the universe. Well, under the assumption about the size of the universe, there is no such x, and so there's no successor of 612. The numbers simply run out at 612. There's no number 613. So there's a problem with putting any number limit of individuals in the universe. There's a problem with doing that. For one, there's the problem that Shapiro says here, because there wouldn't be a successor to 612. There's issues as to what a individual is, how or where we draw the line at what a individual is. So there's many issues with not ascribing to infinity. But then there's a problem with this axiom. There are infinitely many individuals. Now this is not, out of an axiom, we're looking for an analyticity, a priori, necessity, in truth, or can it be proven true? But then Russell says this is essential for the development of arithmetic. Now this axiom will give you the idea. It will give you the luxury of being able to have a successor to each number, and not have the problem of ending at 612 or some other number. Now, that is a problem, because Russell claimed this axiom as a postulate. He's postulating this. Now, this was a problem for his logicism. Russell admits that this principle does not enjoy the epistemic status of the other fundamental principles he employs. The axiom of infinity cannot be proved, nor is it analytic a priori true of necessity. Nevertheless, it seems to be essential for arithmetic. The existence of each natural number and its successor then follows. Frege proved that each natural number exists, but his proof is impredicative, violating type restrictions. And now this is a problem, because I guess Frege proved this because of this idea, because he had not come upon this idea of impredicativity, and that's what caused his little problem in his Law 5. So he proved it without this consideration, but then with this type restrictions, this axiom of infinity cannot be proven. So there's a problem here. So since there's this problem with this axiom of infinity, there's a problem, because there's because of this axiom, there's a problem there with this logicism. Now there's another axiom. There's the axiom of reducibility. Principle of reducibility, which states that at each type for every class C, there's a predicative level 0 class C prime, which has the same members as C. The principle of reducibility states that no new classes are generated beyond this first level. This allowed Russell and Whitehead to restrict the locution all classes to all predicative classes, and then proceed with the derivation of the basic principles of arithmetic. So basically, what this is, it's stating that we have a collection. We have this class C. For every type of this class, there's, let's say, this is basically an issue of this is where the idea of impredicativity and predicativity comes into play, because this is what a level is. There's levels, beyond 0 and 1, but the level 0 is level 0 of any certain type of a class means that this is predicative. So let's say we have this level 1 type 2 class C, and it's impredicative. Level 1 means it's impredicative. Now, earlier in this video, I discussed what impredicative means. That is a problem because we cannot have that. It's difficult, to move forward with, given the vicious circle principle. So essentially, what it's saying that you aren't creating new classes because of predicativity and impredicativity, and that they're the same, in that that they have the same, that they basically have the same members. The class C, the predicative type 2 class C has the same members as the impredicative class C, type 2 class C. So the principle of reducibility states that no new classes are generated beyond the first level. This allowed Russell and Whitehead to restrict the effect of the principle of reducibility is to allow the logician to ignore the level hierarchy and proceed as if impredicative definitions are acceptable, and the vicious circle is not really a problem. And then this is the same question comes here for this axiom. Is it analytic? Is it a priori? Is it true by virtue of necessity? Is it is it true? Can it be proven true? Now, what this is saying here, this is these two principles, infinity and reducibility, are criticized. They're criticized based upon that they are extraneous and they're being added on as to prevent the fall of this logicism. And what Russell does here is that he states that it's necessary for the development of of arithmetic, and he makes it a postulate just like the axiom of infinity. So let's go back to the idea of impredicativity and why it's a problem. An impredicative definition. It contains. It refers to a collection that contains the defined entity. Like Napoleon had all the qualities that make a great general. Now, qualities. If this is to be predicative, the word qualities has to be defined without. Without including the definition of qualities having all the qualities that make a great general. So the word qualities cannot have the qualities that make a great general in there for that definition to be predicative. So the problem here is the paradox. The problem here. To generate the paradox, we define a concept R which applies to an object X, just in case there was a concept F, such that X is an extension of F and f of X is false. The definition of R refers to all concepts F, and R is just such a concept F. Thus, the definition of R is impredicative. We derive a contradiction from the assumption that the definition of R holds its own extension. So that's why it gets banned because of the paradox. The paradox of the barber, Russell's paradox. Now that's a city of people who don't shave themselves but are all clean shaven. Now the barber shaves them. Let's say the barber shaves them. They don't shave themselves, and they're clean shaven. The barber is also clean shaven. But this town is full of people who are clean shaven, who are clean shaven and yet don't shave themselves. So that's the issue, that if the barber shaves himself, that's paradoxical, and if someone else shaves him, then that's also paradoxical. So that is we have a class in that example of Russell's paradox. We have a class full of people who don't shave themselves. People who don't shave themselves and clean shaven. Now this includes the barber. The barber is also a part of the city, and he is clean shaven. So he shaves all of them. And he's the only barber in town. And they don't shave themselves. So if he shaves himself, that's paradoxical just as much as, So him shaving himself is paradoxical. So that's where the idea of an impredicative definition comes from. Because this class is being defined in terms of a member in it. The class is being defined in terms of the barber who shaves everyone. So that is the problem there. So then we come to this axiom of reducibility, which states that at each type for every class C, there is a predicative level 0 class C prime, which has the same members as C. Now this is apparently, I think this seems to me like a cheap get out of jail free card, which is nice, but then there's the problem is, can it be proven true that no new classes are generated based on predicativity? So, using the principles of infinity and irreducibility, Russell and Whitehead established the standard P&O axioms for arithmetic, and thus all the usual theorems concerning the natural numbers. So he went to higher branches of arithmetic with these two axioms. And then there's a different axiom here. Axiom of choice, where is it? Axiom of choice, where is it? Axiom of choice, stating that for any collection C of non-empty classes, no two of which share a member, there is at least one class containing exactly one member of each. So we have this axiom of choice, or if we have a collection C, a collection of classes A, B, C, X, Y, and Z. Then we have the extensions of those objects objects X, Y, Z, and A, B, and C. So we have function A of X, and we have these extensions, and then we have the class alpha, which contains an object out of each of the classes A, B, C, X, Y, and Z, which are classes of the collection C. That is what the axiom of choice is. Now this is what is ascribed to for what Shapiro says for real analysis. This is another one that you would question its ability to be proven true or false, the bivalence, and as well as this is another axiom where we're going to have question as to its a priori and its analyticity and stuff. So that is that issue there. Now, but mostly I'm concerned with the axioms of reducibility and infinity. Now, the infinity, I want to talk about the ideas of infinity and reducibility with respect to the idea of what the logicist wants to do. The idea of logicism is to take logical axioms, logical principles, not logical terminology, but logical principles, and build arithmetic on top of them. And it's also saying that we can reduce mathematical entities to logical objects. So that's what logicists are trying to prove. That, Frege was a realist in ontology, and Russell shows in his later works that he's not a realist in ontology. That I'm going to also discuss here. But essentially, the question here is, with these axioms, which Russell claims as postulates, can there still be a good attempt at, creating a program like this with these types and levels? Types, I think better classify the numbers. They do better to they do better to show how numbers can be moved into at least logical terminology, and even maybe possibly logical principles. But the question here is, given this, first of all, let's think about this axiom of infinity, saying that there are infinitely many individuals. Now this, to not run into problems, you have to, the logicist in Russell's position has to ascribe to this. You can't allocate how many. You can't just set a certain number like 612. You can't just set a certain number of how long you're gonna go. You can't set a certain number of how many individuals there are in the universe. There you have to ascribe to this. But then, given to logicism, thinking about logicism with this axiom being postulated, is there still is there something that can be done here? I guess my question is, can we get logical axioms given the idea of infinity? That is a problem. Russell even said that puts a damper on logicism. For reducibility, saying that no new classes are generated based on levels 0 and 1, or predicativity and impredicativity, predicativity and impredicativity based on a certain type 2 class C. That is problematic because I think it's kind of an issue because you can make that into a good thing for the logicist by not having to worry about this idea of predicativity within your classes, and and you only have to worry about types and not have to worry about types and levels in predicativity. You could just go on given this axiom. So, but the problem here, so basically they could ignore all the level stuff and just go on building their arithmetic. But then there's a problem here as to as to is this really true? Is this a good thing to ascribe to? Because I think that they're actually, if we're using this type theory, I think that there actually are different classes, and I think that there are different. There may be. Let's say we have a class C or in Frege's terms, concept C. Let's say the concept is redness. And I think by the idea of impredicativity, there could possibly be within that class members that have the same concept in it. So I think it's very possible that there are different members in the class C based on its level 0 or 1. So that I think is problematic because it's also you aren't exactly sure as to whether there are the same members in the class C level 0 and class C level 1. You aren't exactly sure about that. And the basic charge, and that's just, it's mostly with this axiom. The problem is not that there are more members in the class level 1 than there are the class level 0. The problem is that you can't know for sure, and that you cannot prove this principle a priori analytic, or you cannot prove it true. I mean, you can't prove it analytic or synthetic a priori or a posteriori, or you cannot prove it true or false either, because you don't know exactly whether there are more members in class C level 1 than class C level 0. You don't know about that. So that's the problem there, because we're basically saying that, given the vicious circle principle, that you're saying that these two classes have the same members, so they're the same. So they're saying that the impredicative class C is reducible to the predicative class C, which is problematic because you don't know that. So I guess given those two axioms, there's a lot there that you don't know. There's a lot of things there that you don't know about. You don't know if there are infinitely many things in the universe. You don't know. You don't know if there are members added based on predicativity or not, or members lessened or increased. You don't know those things. So that's where there's problems. But then there's later in Russell's Introduction to Mathematical Philosophy, I think is it's called. He had this no class theory, that he's saying that classes are not logical entities, and they're fictional creations. They are logical terminology and not logical principles, is what he was saying. Frege was a true realist in an ontology. He had a logical ontology where there are logical objects which can be formulated into mathematical objects. Where Russell later in his writings just kind of, he looked at all these classes and stuff in logic and mathematical logic and said, well, these are just things formulated for the purpose of logic, and that's all really. So that is my video on that, because I'm interested in that, and for me that doesn't give a very good it doesn't give a very good case for logicism as of yet. And I do have a certain thing that I believe in, that I do argue in the philosophy of mathematics, which comes much later after this logicist period. So yeah, but next I'm going to talk about Carnap. So yeah.